lesson, I'm going to overview index fossils, which are used to determine relative age of fossils and rock layers. This slide here outlines what I expect you to know. So if you'd like to pause it and review it, please do. Here are some key terms that I will be using during this presentation. So if you'd like to pause it, summarize it, and review it, or refer back to it, you may. So the main idea of index fossils is really they tell us their relative age. They're a useful tool to tell us the approximate age of one rock layer or one fossil to another. So they're used for determining the approximate age of rock layers and fossils. Index fossils do not tell us the exact age, but they are extremely useful in telling us the approximate age of rock layers, fossils, and nearby fossils that may not be index fossils. In the previous lesson, we discussed the law of superposition, and now it tells us how we determine the relative age of rock layers. And in this presentation, I'll be outlining how index fossils tell us the relative age of rock layers and fossils. So this picture right here shows us some common index fossils. For example, if we find an ammonite fossil in rock layers, we know that those rock layers must be approximately 65 million years old, approximately the age of the dinosaurs. And if we find trilobite fossils, we know that those rock layers and the fossils nearby must be, about 521 million years to about 240 million years old. So those are relative ages, those are approximate ages. But when we find trilobite fossils, we know approximately the relative age of those rock layers and those fossils. And if we find ammonite fossils, we know they're approximately 65 million years old, or the fossils and the rock layers nearby must be about the age of the dinosaurs. So those are some common index fossils and how it tells us a relative age. Some characteristics of index fossils. There are some specific characteristics that are necessary for a fossil to be considered a good index fossil. There are many, many fossils that don't meet these criteria, so they would not be useful in determining relative age. So these four characteristics I would recommend summarizing so that you could refer to them in the future. But if a fossil exhibits these four characteristics, it would be considered a good index fossil, such as fossil, which is one of the most widely used and common index fossils to determine the relative age of rock layers and fossils. So first and foremost, it has to live a short period of time. If a fossil or if an organism lived over an enormous amount of geologic time, it doesn't really help us narrow down a small relative age. So one important characteristic of an index fossil is it has to have lived a short time. So an ammonite fossil lived a short amount of geologic time relative to other organisms that may have lived a lot longer. A second characteristic is it has to be found in rock layers. So they have to be, we have to be able to find them. So it wouldn't be a very good index fossil if we're just not able to find them and use them as references. The third is they have to be found over a wide area, because if we find them in one area and then in another area on the other, somewhere else in the world, that's very helpful, because if we're able to determine, the relative age of one, then we can make inferences about the relative age in another location. But if they're only found in a small area, it only helps us determine relative age in a small area. And last but not least is they have to be unique enough in order to be able to differentiate them among other fossils that may not be index fossils. So, for example, there are a lot of shells that are just so similar that they're not unique enough to be able to identify them as index fossils or not. So very important, they have to live a short period of time. We have to find them all over the place, and they have to be unique enough in order to identify them. So an ammonite is a great example of an index fossil. We know if we find an ammonite fossil, the rock layer that it exists in and the fossils around it have to be approximately 65 million years old. So be sure to summarize these characteristics and refer to them, study them. So how do we actually use them? How do they work? We use them to estimate the age of rock layers, or the relative age. It gives us a range of the approximate or relative age that those fossils and rock layers could be in. And then, as you guys are going to see as the presentation goes on, is that even fossils in those rock layers that aren't index fossils could be dated relatively. So they're extremely useful. That's why they're called index fossils, is because it's an index of the relative age that the rock layer and the fossils around it could be. So it is used to date other rock layers and other fossils. So here in this diagram, we know that this particular fossil here is a particular relative age, and then in another location we are able to determine the age of the relative age of this fossil in this rock layer, and ultimately the other fossils that are near it. And then according to the law of superposition, we can make assumptions of how old the fossils are in the layers above it and how old the fossils relatively are below it. So fossils that are found in many rock layers are just not good index fossils. So for example, take a look at this gastropod fossil here. Because the gastropod is found in many rock layers, it did not live a short amount of geologic time. So the gastropod is just a poor representation of an index fossil, simply because if we find a gastropod over here, we don't know relatively how old this fossil or rock layer is, or the fossils around it. So a gastropod is a poor example of an index fossil. On the flip side, though, let's take a look at this. Trilobite is a good index fossil. However, it's not really found over a wide area. So the trilobite in this case is not very helpful, because the trilobite isn't able to tell me how old any other rock layers are. So in this particular diagram, the trilobite would not be a good index fossil, simply because it's only found in a small area. So if we take a closer look, maybe the ammonite. So let's look at this ammonite fossil here. So we got one ammonite here. It lived a short period of time. It's unique enough where I can identify it. And then maybe it's found in a wide area at many different locations. So let's say this area, we know it to be about 65 million years old relatively. Then I could make inferences about this layer here being approximately 65 million years old. And then at another location far, far away, I could also determine that this is approximately 65 million years old. And then according to the law of superposition, we can make inferences about the fossils around it, and also the fossils in the same rock layer. So I know that even though the gastropod lived over a long period of geologic time, I can make inferences that this particular gastropod, since it's in the same rock layer as this ammonite, this gastropod must be approximately 65 million years old. And I know that this one is significantly older since it's in lower rock levels. So just to summarize, this gastropod is a poor index fossil, simply because it lived over a long period of time and it doesn't help me determine any relative ages, whereas this ammonite is a great example of an index fossil because it lived a short period of geologic time. It's only found in a few rock layers. It's found in many locations, and it helps me determine the relative age of rock layers and fossils around it. And that's a great example of an index fossil. So here's another diagram kind of summarizing what we just went over is, if I know the age of this rock layer and, these fossils, and I go to another location, and this is called Site B, I could determine the relative age of these fossils and these rock layers right here. So that's what index fossils do, is they kind of help us determine the relative age of other locations. So which of these would make the best index fossil? Well, if you take a moment to analyze this diagram, you could see that first you got to ask yourself, did it live a short period of time? It found in few rock layers. And then are those rock layers, found over a lot of different areas? So right off the bat, I'm going to say this shell right here is not a great index fossil because look, it's found in, many rock layers. So here, it's not really giving me a narrow relative age. It's existed for a long time. So I'm going to have to eliminate the shell there. The fish, I think, is even more obvious. Not a great index fossil simply because it's found in newer rock layers. It's found in older rock layers. It's lived a long period of time. But when you take a look at this particular shell, it's unique enough to identify. It's lived a short period of geologic time. It's only found in few rock layers, but it is found in many locations. So if we know that this fossil is, approximately 100 million years old, then I can make inferences that this rock layer and the fossils and the rock layers nearby are approximately relatively the same age. And then in another location, I could determine the relative age of this rock layer and the fossils near it. So the shell would be considered the best index fossil for the four characteristics that we outlined in the beginning. So in this particular diagram, very similar, you see we have this particular fossil here. It's found in many rock layers, so it is not considered really a useful index fossil. And then same thing here, this brachiopod looking thing is also found in many rock layers, so another not useful index fossil. But this fossil right here, which looks kind of like an ammonite, that tells us that this rock layer in another location, in this case South America, this gives us the relative age of these fossils here. So even though these two aren't great index fossils, we could determine their relative age because of this index fossil right here. So if this is approximately 65 million years old, then these fossils here are approximately 65 million years old, as well as the rock layers. Similar, if we go all the way over to here, we're in Europe now. This index fossil here, if we know it's 65 million years old relatively, then these fossils here are relatively, and this rock layer here is relatively 65 million years old. So this ammonite here is a great example of an index fossil. And the layers won't always line up horizontally, so that's where index fossils are extremely helpful. Another great index fossil is this trilobite here, because it's only found in a short period of geologic time, but it is found over many geographic locations, and it's unique enough for me to identify. So I know if a trilobite is about 521 million years old, then I could assume that this rock layer here, I can make inferences that this rock layer and this brachiopod is approximately 521 to 240 million years old relatively, as well as in other geographic locations. So that's what index fossils do. This trilobite's unique. It's in many rock layers. It's found in many areas of the world and lived a short period of geologic. So the trilobite and the ammonite are great examples of index fossils that help us tell us the relative age of other locations. And these other fossils aren't necessarily great examples of index fossils at all, because they lived a long geographic time and don't really help us determine relative age. So in conclusion, most often all we really need to determine is relative age. Absolute age isn't as useful as you might think it is. So if we could determine the relative age of a fossil or rock layer, we could compare it to the age of another rock layer or other fossils and determine, approximately how old they are. Relative age certainly doesn't tell us the exact age, but it does tell us approximately how old the rock layers and the fossils are, which is very useful. We can determine relative age using two methods: the order of the rock layers, the law of superposition, and, as we outlined in this presentation, index fossils. I hope this was helpful. Thank you for listening.